Yeah, this time I actually am recording, so we've stopped our political ranting. Oh my God. So we're here today to talk about compilers, language runtimes, implementations of programming languages, anything and everything along those lines. Typically no set agenda. I have a little bit to talk about and in the simple front, and then we'll just let the conversation go from there. Ooh, look, Simon's gonna show up too. That's it. Anyone want to say something to start, or I will talk about the state of simple. And that was a big silence. So let's just do this thing. I don't have anything super obvious, super non-obvious. I'm going to declare the register allocator done this weekend. If anyone else wants to pile in and add comments or read code reviews or anything, otherwise I'm going to declare victory on it. The allocator seems to be doing a good job on x86, ARM, and RISC, and on Derek, who's not here, strange ass weird DSP AI chippy thing also. So I think it's in reasonable shape. There's 1,000 more heuristics that could go in. There are plenty of places I can see improvements, but it's not doing a bad job. It's doing an okay job. As far as a tutorial, I mean, register allocators are a PhD thesis, so I don't know how you fit that in a chapter in a
So
tutorial.
what would be needed in order to become industrial grade allocation?
Oh, a lot
alloca-
more code to run on. So you always test register allocators statistically. At any given point, you'll always have a program that produces a really bad allocation or a stupid allocation, not even a bad one, but just something stupid. And you'll be like, why did it do this? And then you want to go tweak a heuristic and you fix it and the spill goes away. And so this is a better answer. And then you run your statistics and you lost in 20% across everything else in exchange for 0.1% on this one.
So
And that's sort of
this would be the case to gear the register allocation for a heavily used case if you have. So if your company are doing something that would be the test data and you gear
yeah,
the register allocation heavily
yeah.
for that.
I think few companies have a private register allocator. I think some
Mhm.
do, but not a whole lot. That this is it's a large piece of delicate work. Fine.
What mileage you can get from fine tuning that?
In the land of Java, I would get across the board 5% speed up improvements every time I did a hard look at the register allocator. To compare and contrast that, nearly everything else we did that wasn't to do with hot loops had statistically insignificant, not above noise improvements. If you had a hot loop doing something hot and you noticed that you had to inline a vcall that needed something tricky to inline or whatever, that one loop would speed up and its friends would speed up and no one else would really suffer. um, but that would be a very targeted, some modest set of methods here and there sped up. The allocator, every time you went in and it took a while to go in and do something useful, you get another 5% across the board. Everybody would speed up. So it's a key piece of performance for, any large industrial grade, as you said, industrial grade system.
So by large, tuning the register allocation around loops will be the most heavily used section of the code.
So every time you have hot code like a loop, if you can tell the allocator it's hot, loop nesting depth does an okay job.
Mm.
Um, it'll do the right thing. You arrange for that one to work. So you should expect to see reasonably good code around loops all the time. Um, it's when you have big complicated applications, it's all a giant warm fuzzy ball. And there's not a lot of super hot loops that take up a significant portion of the application. HPC computing, yeah, all the time. Big applications, no, all loop trip counts are modest. And, it's 1 to 10 as you count the number of people that pass your filter, or the number of files are going to do this, or a number of whatevers. It's just not a large number. So super good performance on loops and bad elsewhere isn't the right thing to go. You have to
Is
handle the big mushy cases.
is there a situation that when you're trying to tune one thing, the other thing will become
All
unbalanced?
the time.
So you have to take some a balanced approach to make both
Yeah.
perform as best as they can.
That's what I
So
was saying about statistics.
mhm,
100%, if you fiddle something here, something got worse over there. It's always a whack-a-mole game. This mole went
mhm.
down, that mole popped up, and you play statistics. So the simple chapter 20 testing counts spills weighted by loop nesting depth. And every time I would tweak the heuristic, somebody would fail. And I would go add in more and fiddle. And then periodically I would get a win where everybody passed except several people, a couple of guys who I know had kind of ugly allocations got better, and they would just have a drop. And so I'd lower the tighten the bar and say, you have to be this few spills or fewer to be okay. I just don't have a big enough corpus to do a really good job on a larger set of things. That's just what it is. And that's not going to really change until I think strings and then encodings, execution strategy, strings, so you can print and do I/O. And then it makes sense to like look at some standard library things and write some more snippet code. And then I have to go back and do like error messages. The error messages suck in simple right now.
Mm.
Basically, the first time I get a parse error, I just throw it and
So
walk away.
would the situation improve if if we introduced inlining keyword at the source level?
No,
Uh,
I don't have enough code.
mm,
So right now, I'll inline things that have single call to single method, and then not elsewhere. But inlining heuristics could totally happen, but they don't make sense to you have a large enough corpus that you can see, like other than test cases.
and I meant inline as a keyword in the language.
Yeah, right.
So
But I'm saying I don't have any code worth inlining. First, you have to have some code. Then you can add an inline keyword to tell it to inline. But then you have to compare the inline keyword versus an inline heuristic.
yeah.
And I can do inlining heuristics.
Mm,
Uh, that's not necessary, I think, at this point.
mm, yeah.
So inlining is a key performance transformation. You need to do it. Yes, you have to have some code to inline, and we don't. So I say we. It's whoever's hacking on simple right now. Which, to be honest, there's a couple of guys who are pretty steady at it, and lately it's been Tomi. I don't have his full name, Hadhazi or something. And I'm going to mention him because I was trying to get him on, but he has been pounding out encodings
Yeah.
for x86 and now
Yeah.
RISC, which is getting close to being done.
Give them proper shout out. So they are doing great job. So
Yeah,
yeah.
yeah, doing a great job. Oh my God. So my theory here is that next week, like this week, I'm going to turn the register allocator and say done, unless somebody comes up with a new bug or a new issue or something. And then next week, I'm hoping to turn on encodings as chapter 21, and we'll have machine code bits. And then
Yeah. So
chapter,
what would be encoding? What is the gist of encoding purpose? Hmm.
well, I want to get an ELF file and then be able to run it.
Okay.
I want to be able to go to Godbolt and compare against Clang.
Okay. So that would be the code became executable. So
Yeah, code becomes executable. You have to
okay.
have some relocation. So if you're a JIT, you can slap it down and run the relocations yourself, and it's very straightforward. But if you want to go out to a disk file, you need an ELF format. You have to write relocation stuff. Yasser has been volunteering his ELF writer. Apparently, he's got a Java version that is been playing with Tommy with. So
Cool.
there's some hope that encodings will either have an ELF presentation or that'll be a chapter immediately following. But I think those two will happen shortly. Um, and sometime in the next couple weeks, we might have disk file format we can immediately execute. That would be cool. Going to have since there's no strings, there's no printing, all functions will just have to be checked via the error code on exit.
Hmm.
Fine.
Okay. After that, so the encoding, and after that,
Oh yeah,
we
roadmap. Yeah, roadmap type. So after
yeah.
after encodings, and whatever ELF file if that goes in that chapter or not, it's going to be heading for strings and IO, so you can actually do something.
Mm.
So both of those in any order. IO is probably going to be me adding a namespace called sys or system or something, and
Mm.
under the namespace will be foreign function calls for IO, and anything else you might want to throw in there. And I don't know if there'll be an import keyword or not per se. There probably shows up an import keyword.
So would it rely on libc or something, or maybe something else in order to enrich the?
Well, right. So to get right, in order to get IO from an external format as opposed to, if you're jitting it, then it's in the process I'm running, which is Java. So then I use Java's hook on libc. But if
Mm.
I'm making an external call, then it probably, writes to libc. Yeah.
Okay.
Hey Andy, it's been a long time. And yeah.
Hello.
Hi. Yeah, welcome to Coffee
Having a
Compiler
problem.
Club. Yeah.
Yeah, thank you. Yeah.
We're yakking about, I don't know where you looked or how you ran across us. We're talking about I'm writing an open source, fully optimizing, full-fledged compiler that, in theory does something similar to what LLVM does, but in a tutorial format
Yeah, you're
using
writing
CF
you're
nodes.
writing a tutorial in a
I'm writing a
book,
tutorial.
and as a side effect, you're building a compiler.
Yes.
Yeah,
So,
well, sounds cool. I have dabbled with LLVM in the past, and it's I don't
So,
know. I
well,
think
we're
it's
waiting for the paper book.
the
I
goal
will
here is
order
to
it.
not have to dabble in LLVM ever again.
well, I stopped, but yeah.
So, Cliff, is anyone looking at doing a backend for simple on LLVM?
Somebody's doing simple itself in a Java emulator in the browser. Talk about layers upon layers upon layers. This is a back end. So I'm sorry, what are you asking? So simple front end goes to an LLVM backend.
Yeah, I'm just curious if
I
anyone.
haven't heard.
I mean,
I
you just
have
got to
had
find
requests
find another
for
volunteer.
a simple C of nodes IR be dumped out as an executable format so that people can hack the IR and add more things to it or whatever. Like if you're looking at a real optimizing situation and you just figured it's still going to be ahead of time, but you want to enable as much sort of optimization. It's like whole world assumptions. So your .o file just has the raw IR in it. And how dense can I make the IR? Well, I can make the IR really dense. So something on the order of, you know, Java bytecodes in half or something. So something fairly dense. Put an interpreter on it. You can interpret it directly, reasonably okay. Not, it's not that great, but it's not that bad either. And then if you pulled in some other .o files that had the same format, you just stitch the graph edges together and let the optimizer go to town. You get a whole program, chunk of program, whatever, how you want to do it. So in my head, a long time ago, there was gosh darn it, wouldn't it be nice if we had another virtual machine out there that was more accessible than the Java virtual machine? And that's one of the reasons I was thinking on and off about simple. And then Debian, who
Mhm.
doesn't show up anymore, poked me and said, "Hey, do this thing." And I thought, okay, I'll help you do this thing. And then after a while, I got more excited, and he he got less excited, and he moved on, and I'm still at it, and kind of enjoying it. This thing's, it's got
Are you
some legs
talking
now.
talking to Vendu or?
I talked to him on and off. He pokes up on Reddit in the compiler section, and he ends up asking questions. And the first few times I didn't, he had a different name, so I didn't know. And he asked questions. I said, "Hey, check this out." And then he was like, "Oh, he learned compilers like no formal theory from scratch using simple and C of node." So then he had to go learn how other people did compilers, because this is obviously, he learned this, but why is it better or worse? You got no context to say it's better or worse or what. So he's off learning other things, and then I don't know. He shows up occasionally and says, "Hey, this is awesome," and then goes away. So who knows?
Hmm.
So I'm still hacking simple, and now there are more people being on it pretty reliably here. Like I said, Tony's been pounding on it on the encoding side. Um, Roadmap. I was doing roadmap. So reg allocator's done this week. Encodings are done, waiting on the reg allocator. The ARM encoding probably takes a while to show up because ARM is just a bitch to encode. L file right after that. And then we can put code out and look at, how it does compared to LLVM. Maybe get some Godbolt thing going, something like that. And then,
Do I get it right that at this point you don't yet generate any assembly, so you're not yet
yes,
there?
yes, we do.
Oh,
We
you do?
don't,
Okay.
we don't encode. So if I
Okay.
run the register allocator and I stop it at the encoding stage, I get not encoded, but full assembly with proper register allocator. And I can demo that. And I've demoed it in the last several weeks, but I can demo again.
Oh, okay.
Yeah, sure. We can do it.
Okay, I'll get there in a minute. We can do roadmap, and then we'll throw out
Yeah.
encodings and unencodings, register allocation, well, up through register allocation encodings.
Okay.
Okay, post encodings we need strings and file IO. So there's probably some sort of import mechanism to get IO. I haven't figured out what to do. I don't like the import keyword, but it has its place. Some variant of the import keyword has its place. So something happens there. I guess I'll be open to suggestions on how to go there. I know Aaron always wants the AA side to do Python style. But if you have
So
all
you
your
say
imports listed up front,
you say not exactly import. What kind of imports are you
well,
managing?
there's if you have a list of imports that are easily, readily available, then you can bring in tools that gather across imports. You can bring in module building or whatever, dependency analysis tools and the like. So
Yeah.
something happens there that you want to say it's easy to do some sort of dependency analysis game. I don't, like I said, I don't know where to go with that yet. It could be as stupid as it's a Java style import and I'm done and walk away. But I'm
I
hoping
also
there's
like to not have all my code in one file.
better answer. Well, right. Well, yeah, right, exactly. So some import mechanism needs to happen here. And that's just because Simple started life as here is how you go straight to CF nodes from parsing and skip all the in-betweens. Fine.
So,
So then,
LLVM,
I'm sorry, somebody's trying to say something.
yeah, to the previous topic of LLVM backend, it might be handy to have basically take your graph before instruction selection and Regalog, lower it to LLVM IR, and let the LLVM backend do its job, and just use it as one of the backends, so you can compare what you can get from LLVM, and then tune on it.
So I'm totally excited to have you do that.
Yeah.
I am not an LLVM expert. I don't know anything about LLVM IR. I am not going to learn.
Yeah, not sure if I'll have enough free time to do that, but sounds like a fun small project.
Sure. Somebody else who's got an LLVM knowledge and cares can go take a look.
Yeah, I've occasionally seen lousy comparison to LLVM. Someone has designed their entire language and compiler and stack from top to bottom to use their code generator. And then they roughly pull it out and get some kind of thing that can get LLVM to compile it. And they're like, see, the totally unoptimized, unthought about LLVM thing doesn't work as well as the thing I designed to work with my language.
Yeah.
Sure.
It's the standard.
I don't know if I've
strawman.
actually learned anything about whether LLVM is better or not.
Right. It's a standard strawman argument. And I don't have a large corpus either. So all test cases would involve having some handwritten junky thing that you wrote that showcases what you do good.
Well, I was thinking where you use your own optimizer for most of the things. You use LLVM just as a code gen.
Right. And like I said, I don't know how to do that. I still think it would be easy to fall into the trap of I only look at things that I do well on. It's fine. And then to get a larger corpus, so you get away from that trap, I need to have IO and strings, and then a library of some kind, so people could actually try to write code, and then error messages improved, and all sorts of other things. So all these things are all big future work. It'd be really cool to say that there's a good backend that I have a good backend right now, and I don't know. I don't have a good way to test that.
Is there Fuzzer for simple to fuzz generate? Okay.
Yeah.
Well, already something.
It passes the fuzzer, which mostly catches stupid. Like a better fuzzer could be made. this fuzzer catches stupid things in the parser nearly always, and extremely rarely catches something stupid out of the optimizer. And it's basically quit finding things 3 months ago. It did a good job for 3 or 4 months finding things on a regular basis. And then I hacked it into the build system, and every time I do a build, it hit the go button from every little debug thing. It runs another 100 random seeds through the fuzzer. And
Oh,
these days,
100 is too little.
no,
Like
no, this is my normal everyday make. I'm hitting the go button in the debugger. I edit some code, hit the go button, 100 samples got run. Now, when I go push and I want to say, go, this is getting pushed back to main, over the course of 2, 3 weeks for the rush allocator, more than that, I have done many hundreds of thousands to many modest millions of fuzzer runs.
okay.
Right? No, so yeah, I'm with you on that one, but I have something I run just every single time.
Like smoke test.
Yeah, right.
Yeah, the V8 team that works on Chrome had a good talk about a decade ago about how you have your fuzzer and you run it for a while and it makes your code a lot better. And then it stops working and now you have to go make your fuzzer better. And then it finds all these problems with the code, so you have to go make your VM better. And then it stops working, so you have to go make your fuzzer better.
Right.
Okay.
I'm at the
Or
point.
you just write another fuzzer, and it just by being different, it exposes different things. So
Maybe.
we wrote a few. We wrote like I think 2 or 3, and also evolving them in between of these big rewrites.
So I'm
And
definitely
yeah,
at a point where simple needs a better fuzzer at this point. It's fine.
And you start playing games like fuzzers that have reward functions based on having reached branches they never saw before. And
Yeah,
you can get really deep into fuzzers.
Yeah, this one's not there. This one is randomly produce a valid simple program, and then occasionally also produce one that has a few tweaks that makes it invalid, make sure that it gets negative tests instead of positive. But mostly
yeah,
the dumb. The optimizer often finds, mostly the dumb. The optimizer finds big chunks of dead code, throws 90% of it away out of the parser. Yeah, fine. Better fuzzer. Sorry.
Yeah, we're not there with the reward function either. And I think like simple fuzzer does the job really well. You just if you're willing to spend compute on it, I think having reward function might probably make it cheaper to run and cheaper to discover bugs.
You need a it's not a reward per se. You need a better exploration. The normal fuzzer has things like if zero or while false all over it. And so huge amounts of the code is trivially dead. And like I said, the parser knows he's parsing dead code, just throws the code away.
Yeah, I mean, it's the same as playing chess or Go. You have one function that's trying to mutate your stuff and one that's trying to just have very large numbers. And you spend some time exploring and some time exploiting the places you found.
So there's no exploration in simple right now. So it's a black box as opposed to a white box fuzzer, which asks a question. If I tweak the program this way, I get past this particular point in the optimizer or something. There's none of that's going on.
Right. So I would say your explorer is randomly generates syntactically valid code.
Yeah. Right.
And your exploit is, did it crash?
Right. And we need a better one that's not so random.
It's a cheap evaluation and cheap exploration. But the result of that is you have to do it a lot of time to get good coverage.
Yes.
As your exploration gets smarter and your scoring gets more fine-tuned, you can get away with having less rounds.
So are you gonna implement this new improved fuzzer? I'm looking forward to it.
I am not. Convince the VA team to do it.
Exactly. Okay. So the state of the world.
I mean, basically, the VA
like...
team only got a good fuzzer once they decided that it was 6 people's full-time job to do nothing but make the fuzzer for VA. And they had a really good fuzzer 3 years later.
Right. Hotspot eventually got there via the other approach, which was it just got stupidly popular. Hiram's law kicked in and every possible program on the planet showed up.
Well, C2 had the advantage that there was already a user base and a lot of code in the world when you started.
Yeah. We went down the road of fuzzing, and we had I would say I was at Sun. There was a Russian engineering team, and they went down the path of doing a lot of really interesting testing. And I don't know if they were fuzzing, but they produced tests that were sort of doing all kinds of fun corner cases after they had to do all the setup to get through, and the C2 would be kicking in and trying to compile shit and stuff. All right.
So I think large user base will not help you find security problems.
Yeah.
Like if you are trying to make it stable for normal use case, yeah, that's fine. Just have enough users and flesh out bugs this way. But if you are trying to make a robust system that is secure, like no one will be able to exploit it and like make it crash and do something bad by exploiting it, then yeah, you need to do something else like fuzzing.
Yeah. Like I lived through the hotspot one, and the answer there was it worked great on the normal shit. And so it's the same as the standard fuzzer. You quit finding things. We just had a much larger set of people testing.
So I got a
But
question.
simple does not yet generate enough revenue for that team.
That's right. That's right. Sorry, go ahead, Bill.
What's the fuzzer testing?
Well, in the beginning, it tested whether or not I would handle various syntaxes. So there
Okay.
was easy things that I thought I passed and I didn't. And then it started finding negative syntaxes, things I should have failed and I allowed.
Okay.
And then it started finding occasional bugs in the peephole optimizer where there was an opportunity to do something, but it didn't make it on the work list. So the peephole optimizer is all incremental.
Yeah.
Means it looks for deltas. It was failing to catch a delta, didn't get on the work list. You missed an opportunity. Okay, so those all got beaten down after a while.
But the third one, your fuzzer at the end of it, it's looking at what the peephole optimizer did and said, wait, it didn't do this and it should have. Is that because the first two,
No,
it's like, does it compile or does it not compile?
right. So it
That
still
seems kind
doesn't.
of easy to.
Right. It does it compile, it does it not. The peepholer has an expensive, order in squared assert that he runs, um, that can be turned on or off. And if you run an assert on, he will detect a missing peep that should have been on the work list, an error in your delta calculation for when you made a modification. And all that does means is the peepholer runs and the program crashes with an assert. So as far as he's concerned, the compiler crashed.
Oh, I see.
Yeah. So it wasn't the program or compiled to an error message or not. Compiler crashes internally with an assert.
Yep.
Yeah, so you run all these with asserts turned on just for that reason.
And then is there a stage 4? You said that's the third one.
Yeah, so stage 4 sorted very rarely would find cases in the peepholes that were failed what I call the Church-Rosser property. So the Church-Rosser property for lambda calculus is I can do my beta evaluations in any order, and I get the same answer. And if you look at the possible valid program states in the universe, there's a tree of all possible combinations, and you all end up in the same spot in the end.
Yeah.
So simple ones, these peepholes, one of my goals is to get the same answer in the end if you run them in any order. So just go on a work list. You pull off the work list in any order, you do them. Okay. Every monotone analysis framework relies on the same strategy. I don't have a formal proof. So instead, I do this with statistics and engineering. And so you run different random seeds that run the work list in different orders and see if you get the same answer in the end. So statistically speaking, it is, extremely likely that you'll get the same answer on all simple fuzzing tests, because if you didn't, I'd already thrown that. So I don't have a current test case where I'd get a different answer.
I see. Huh, that's interesting.
But it found some.
So the point of that is because you don't have a proof, you're actually testing and making sure that it doesn't matter what order you do the optimizations in.
Yeah.
But some I would say some optimizations is so you do optimization after inlining or first inline and then do optimizations. So they have to so that's the other properties, because you stay monotonic, and if you retire them, then the second time you try to inline and then you continue. So you have to stick to these properties.
So I have definitely had cases where I detuned a peephole so that I could remain Church-Rosser stable or monotonic if you want. There are very oddball cases where I had ands and adds and merges around feed functions where I would know sub-bit pattern manipulations in one side and not on another, and I would drop a little bit of information about which bits were zero, which weren't. That was the only place so far I've detuned. Now, I don't have any inlining heuristics except for the one that says single call calls single function and 100% inline. So that one happens no matter what because you can't get rid of the function and you can't get rid of the call, and so you always get it or you don't, or it's not there, right? Later in life, you'll obviously come to the point where you have to say, here I have a set of inlining choices, and if I make some in the wrong order, I'll fail to get the others or something. Something might happen there. You can totally imagine that. And so that one will require more thinking to preserve the monotonicity patterns here.
Yeah.
I think it can be done. I went a long way down this path on AA already, so I think I know where I'm headed with it too.
If you have multiple files, is there still a guarantee that like you always get the characters in the same order?
You mean the parser?
Yeah, so
I'm not
like
sure what you
I'm
meant
thinking
multiple
of,
files.
say, a Python script that's just top down. The order in which the dependencies are listed will tell you the order in which to go read the other file.
So if I use an import, then the import will, from one file, will go grab from the others in whatever order. And if there needs to be a dependency set up such that there's a collected set of imports before I begin doing the next step, everyone reads their headers and grabs the union of all imports before we parse anything else, then maybe there does.
There's probably going to be roughly some kind of depth first reversal.
The the peephole optimization monotonicity shall not depend on what order the parser visits things.
Yeah.
So
Yeah,
it
that was
doesn't
my
now,
question.
and I don't see why it would or need
Yeah.
or anything. That's not where you pick that up.
The thing I was imagining in my head is like someone puts an end of file character in the middle of their file. Depending
Oh,
on
the
what's above
parser.
or below that, there's things that the parser never saw or gave.
Parser doesn't care about control characters. He'll run that into file through and say, this is some kind of a syntax error. Okay, you don't compile. Then I don't care what the peephole church roster properties do. You didn't compile it, done.
So the simple case would be an import at the beginning of the file, but let's say like Scala would allow you to import in the middle of the file.
Yeah,
so that would complicate things.
Right. There's a class for name, right?
Yeah.
And then there's eval. And I'm not certain where I'm going to go, how far I can go with all of these. The imports in the middle, I'm going to say no on unless it's eval. And as soon as it's eval, then you open up this other can of worms.
So let's say you start parsing a file, you encounter an import, you jump immediately, or you continue to parse. And if you encounter symbols that that come from the import, what was the strategy here?
If the design choice is that in order to maintain the church roster property, I'm going to have to read all the imports up front to know what I have, then the syntax will be the imports are obvious up front, followed by a non-import and never again an import. So I'll read the head of every file that's part of the compilation, check their imports, check the head of those imports, like go find the class file equivalent. So Java class file simple ends up with the same, .os with the simple IR, whatever, gets the same things out of all of those, runs all those imports together. Now he has the full set he's going to compile in one shot. Now he can do church roster proper things at that point.
Okay,
that sounds like the right choice for simple, but it's probably too restrictive, right?
No, I think this is what every C compiler, every Java compiler on the planet does. So whether or not, and that's independent of class for name. So class for name brings its own can of worms. So outside of class for name, I think this is a simple, here's all the dependencies for this compilation unit in one shot. And I think I think that I'm done with variations that cause issues with when you would get the church roster property to fail on you or not. I'm looking for places that have an IR dependent variation that is structural. So like random is the whole point of the church washer thing. So random is fine. It has to be structural.
But it
I
could be
think
really nice to put imports in if statement where you have some constant at the top level that says this is a Mac OS build, and then you say
Right.
if Mac OS build, do
Right.
this import. If
Yeah.
Windows build, do that import.
That is the AA model, and maybe I end up going there. That's a slightly different one. If I'm willing to say all imports have to be statically determined via control flow, via constant folding, and so that would be run the file through the parser and up
So
through
you just
the
do constant folding first and say
parser
it's
constant
got to either
folds.
be always or never.
Right, parser totally constant folds, right? You run through the parser up to the end, and you run them down to where you've stabilized all the constant folds if import showed up. And then I guess code that uses the import has to be under the same test. It's an all or nothing kind of game there. Then he does. And at that point, I claim, again, the parser being deterministic will deterministically tell you whether or not you're importing, or you got a constant. You didn't get a constant, in which case you have a compiler error because I imported or I didn't. No, that's not a runtime thing. As soon as you go to the runtime thing, that's a val. It's a whole other can of worms.
But if you try the lazy completer way, like Scala, if you say encounter import, you continue parsing, but when you encounter a symbol that you not yet know, the when you parse the other file, it will trigger the completion and it will move all its dependencies on the peephole on the nodes. So in order to continue with what it has on the first file, so that's maybe viable.
I'd have to go stare at what's going on there to figure out what I want to do. There is an obvious thing that I do right now where an unknown symbol just hits the forward reference pile and is supposed to be resolved at some point. And if it fails to resolve, you have to compile error. Okay, done. That's obvious. Now, you have an import that is conditional, and I'm avoiding loading it until I see that it constant folds to being in or not. And then if it constant folds in, it brings the symbol, and then my forward ref resolves, then I'm okay.
So you don't need to go to parse the other file with the forward reference. You can just continue and
it's just a pending. I don't know yet what I don't know.
Yeah.
So the node that you get out of a forward reference is a chameleon. It can fake its way to anything.
Yeah.
And which, by the way, means it produces top in the language. I mean, in the lattice. As I can be an anything thing, and then a bunch of things fail to make forward progress as soon as that happens. Everyone who depends on it doesn't know what to do.
It will be a forward ref which extends node, but it doesn't know at this point what kind of node it is yet. Okay.
Yeah, there is a forward reference node in Simple right now, and I use it for folding up unknown function calls. So currently, I'm only allowing forward refs on function calls. He says that, so let me go. Yeah, there it is, fref. Yeah, there's an fref node. And he claims not a whole lot. He's waiting for somebody to come along. Oh, yeah, and he does nothing useful until such time as he gets defined, and then he just peepholes away as an identity on whatever he got defined to be. And he's otherwise a constant node. Actually, he's a constant bottom, and I need to lift you because you're in the parser. So he's a constant bottom, and he's being lifted. And he can't lift, and nothing he uses from him can lift because they get a bottom input. So it stalls all optimization, basically, until such time as you get a ref for him. So if that stalls you all the way to the end of the parser, it would mean that you didn't define the forward ref. The parser will blow up on you. He'll do his type check and say, no, you fail.
But when the forward ref is resolved, it will try to peephole again to finish all of the optimizations it can.
It's all incremental. So as soon as a forward ref gets
resolved,
defined, you define it by setting an edge from the forward ref to the thing it got defined as. It becomes a copy instruction on the thing it got defined as. All consumers of the forward ref peek through the copy and get to the thing they're defined as. This is all just incremental because on the work list, it all beats its way down. Everyone flows the new thing through everything, and when it stabilizes, you should have
Yeah.
the as if it was there all along value.
I believe the imports would be the same story. So
Yeah,
it's
right.
just
And you can have a cyclic pile of imports that would never resolve, and then that would clear out. If you find a
cyclical
foreign ref at
imports.
the end of the parser, you're dead. You failed to define the thing, so you get tossed out. You get an error. Fine. Yeah. So there's something to do with imports. There is a plan, a weak plan for imports right now. There may be a better plan. The plan may start weak with a theory that can get better over time. Fine. All right, what else? Post roadmap. There's encodings. Let's see, we did allocator done this week. Encodings probably next week because Tommy's been hot and heavy on it, and he's basically got encodings for 2 chips done. And then and ARM can be lazy and follow along. That's fine. And then what was I headed for? Well, an ELF either goes in that chapter or immediately thereafter, and you get an output that we can go run code with. And then it's going to be imports and strings. And the other imports, of course, is defining file IO. And then strings. And then for strings, what I want to do is fold together structs and arrays semantically in the language. So the struct array thingy is just like a C struct that has a trailing array. It'll have some named fields up front at fixed known offsets and a variable chunk at the back end. That's the array. And I'm halfway there already in the type system and the parser. I knew it was coming, so I kept them near each other. So it's not too far to get there.
When you talk about generating ELF files, do you also talk about generating the dwarf debug symbols?
If you want to step up for that one, it's just like, it's how much work and who wants to do it in what order. In my head, the fastest path to getting a more usable language is to get strings and IO. And after that, probably error messages and quality of life for debugging. And somewhere along the way, the debug info shows up somewhere for the quality of life for debugging, but it's not the first thing.
I actually wanted to ask exactly about this, about debug info. Maybe not necessarily the dwarf specifically, but how you would in sea of nodes, what is the generally correct way to link back to source code, given that you're going through so many transformations?
Yeah, right. So in the land of Java, you get full optimization and full debugging. And to do that, you have 2 execution strategies. And the one strategy is the highly optimized version. And periodically, he maintains a full mapping back to the architected Java virtual machine state, which would be a bytecode index. Now, the mapping from bytecodes to source codes is whatever it is. So there's a line number table. Fine. As soon as you're in bytecodes, you can single step in every debugger on the planet, and you're just debugging at the Java virtual machine execution engine state, which is bytecode by bytecode. So that requires 2 strategies. The optimizer only has the mapping back to source code periodically. Between those periodicallys, he gets to optimize full tilt, and that's where all your performance comes from. So safe point.
So do you have file name, line, and character for each node in the sea of nodes?
I do. I start with that, but it rapidly ages. So I can only give you sort of partially that for real. The deal with the safe points is that I give it to you perfectly, but once every 1,000 instructions.
So is the idea there that because basically it's a JIT, you're going to emit these save points anyway. The save points are a good place to put links back to source code.
Yeah, and not because it's a JIT. It's because you can optimize, and then at save points, I can give you the actual true mapping back to the source. So if that happens every 1,000 clock cycles.
But I think it is because you need to support the optimization, and for the optimization, you have this information, and you need to have the opt points rather frequently to have acceptable latencies of the opts. So you're kind of piggybacking on the ability to de-optimize.
Yeah. No, I'm not going to de-opt here. That's not what I'm talking about. I'm saying if I have an ahead of time compiled binary in a classic GDB debugger like scenario where you're not doing any jitting and there's nothing else going on, if you say set me a breakpoint somewhere, you'll stop first at the safe point, get a perfect thing, and then you now have machine code plus some debug info that says here sort of kind of is kind of wishy-washy a mapping back to source code wherever it makes sense. I can have that information, but some of the transformations don't make a clean mapping back to the source. So you'll gradually get more and more differ from the source as you walk through the machine code up until the next safe point, in which case you're back to being perfectly matched. So that's my current strategy.
Oh.
If we get into a JIT form and we're doing two execution or just not JIT, two execution strategies. There's a sea of nodes interpreter, and there is the JITted optimized code. Under that version where I have a sea of nodes interpreter, oh, I have one already. I'd have to have the IR thrown in with the executable. Okay, it's tiny. So you throw the IR in, you throw the JIT executable. Now you have two strategies. Now you can have the debugger stop at a safe point, then walk the interpreted version up to your exact point in your source code and give you a one-to-one mapping as you go. So it is doable, but now you need to have the IR that's mapped to the source code, an execution strategy on that IR, that's Java bytecodes and however you execute on it, and the JITted fast code with deopt points to go back and forth. And now you do need a deopt. And my current strategy right now is I didn't really need a deopt. I was going to get you close, and then you single step through, and then you got close again when you hit a safe point.
In our earlier CCC, we talked about safe points, and the point being there that the safe points are exactly representable in the source. What in the source represent a safe point? So
it's the parser puts them in. All right, no, let me restate that. The C2 bytecode parser puts them in periodically at things that would otherwise could turn into infinite loops. So the obvious infinite loops would be back edges of any loop that you don't know what the duration is, and function calls, entries, which might be recursively infinite.
So what would be, so entering a call block or open parens or something like that would trigger emission?
A function call,
okay,
and a back edge.
Okay.
That's the C2 strategy. This gets you more safe points than necessary, especially after inlining. So periodically he gets rid of safe points until he leaves a dominating safe point on every path and one in a loop, which he tries to get rid of or make cheaper by unroll and jam on the loop body.
So the dominance game is played on the safe points too. So
yeah.
Okay.
And all it means is when you run through the code, periodically you hit a safe point, but the time until you get to the next safe point, he does make an estimate. So it is approximate. You don't get 100% so much, and then the safe point so much at your safe point. The by far and large way common case is that somewhere under 1,000 Java bytecodes, so 1,000 machine instructions, assuming the optimizer cleans the shit out, you get another safe point.
So representing, maybe always come back to the source line. So each node is inside it stores the source line. So you have that anyway in the debugger, only the source line. So that would be a strategy too. So to have any nodes to have to which source line it points to.
It's actually a character.
Okay. Okay.
Fine.
Yeah.
It's really cheap to store that.
I had imagined as sort of my strategy that maybe because it's a C-like language, what I'm making, that perhaps for debug builds you insert a control flow node at the end, or I guess beginning of every statement, right? Because you have statements and expressions.
Can I interrupt your thinking?
Yeah.
That debug build. So hotspot never has a debug build. C2 never does a debug build. As soon as you have two execution strategies, you don't need a debug build. Wrap your head around.
Right. Well, no, I get that. But the thing I'm making, I have debug builds. There's no interpreted. Right. Yeah. So the idea was, okay, maybe you do a debug build, you insert special points at statement boundaries, and then you can sort of run to the next statement. And then you have
good
mappings
however
back.
often breakpoints, you put the safe
right. Yeah, and then okay, so that kind of makes sense to me. The second use case is a kind of Godbolt or compiler explorer use case where it'd be nice to make a tool where I can say, hey, I want you to run this compile of this project or whatever, and then I want to inspect this procedure and give an assembly view of that. And I guess to me that sounds like it requires more mapping because you need to be able to say what made its way into this thing, and you want to correlate emitted assembly to different parts of
Right.
this
So
code.
the IR, the CF nodes takes, like I said, code locations, source code locations, and also carries a lot of type info, like field names and base structures and field offsets with the names and the like. All of that makes it all the way through to the end. So the transformations don't track the source code correctly. They just, if there's two guys and you pick one because they were common, you lost the other guy's thing
Hmm.
as a sample place where you lose shit. But when it comes time to go dump assembly out, I can dump that shit out too. So and one of my to-dos theory is to say, here's the instruction, and oh, I carried a source code location with it. It's one of many common
One of
CC.
many, yeah.
Something happened there, but I have some source code location. Go grab the source, grab the 20, 40 bytes around the center point, and put it off to the side. And so I have an instruction, and there'll be, this point in the middle. Maybe I'll put a little caret or a dot or something. And right here, the parser said I made a node, and somehow that got mapped to this instruction that's coming out. So that's a thing I could do with some amount of work right now, would make the assembly dump probably a whole lot easier to look at when you had large programs, because you would keep getting mappings. So you knew in your head that the mappings were screwed up. And, I do shit where I take, common things that are below a phi and split them up, and they get precise, and then they fold, and then they get common and back down again. And there's all these nonlinear transformations going on. Your source code map is going to get weird. Okay, it is.
Mm.
But you could get something close enough that you can like, oh, I see what happened here.
And it's not one-to-one. You could have multiple different locations in your binary that all map the same byte of source.
Yeah, right.
Yeah,
Yeah,
Particularly if you did something like
function.
unroll a loop.
Yeah, yes. Any function call that gets inline gets a whole slap, a bunch of codes pointing to the same source code. And then the other one is, every global value numbering things makes a bunch of source code slapped to one op.
So every byte in the binary points to a specific character or source code, but not the reverse.
Yeah, let's see here. Every node which produces however many bytes it does. You said byte in the binary, but every instruction. Every node in the IR, occasionally you get multiple instructions emitted from a single node because there's no clean mapping for, especially like CAS and atomic ops and shit. You get funny mappings.
But it will still be the same source line. So
they would point to.
However,
yeah.
However, yeah.
Does it make sense in any way to say, hey, again, for my debug builds, you actually have some kind of accumulating linked list of all the source locations associated with this output?
Up to you. I mean, I actually started on that path on A, then backed off. It was like not worth it to track it at that point.
Right, because it's not that useful, or
no, it's very. The users are limited to compiler writers trying to debug their broken shit, and super high performance guys who've started out with some particular thing they absolutely had to have work well. And they're trying to diagnose why their vectorizer didn't vectorize, why the SIMD didn't kick in, why, whatever hot thing is not going. Occasionally they have weird edge cases, and they're trying to fake their way through the assembly. They're trying to write assembly in C.
Mm-hmm.
And they're trying to see the assembly. So it has to be an assembly reader is the only person who cares. Compiler writers are huge assembly readers.
Yeah, well, maybe it does make sense to me then, because I am sort of both of those characters, right? Of like trying to,
I think most
to get
people on this
specific
call
output
are in there in some way or another. Yeah.
Yeah.
I'd love to see that information. No question about it.
I spent a little bit of time trying to chase this path as well. And where I found it was not worth the effort and I just stopped bothering with it was peephole ops where multiple nodes turn into, other nodes. Like sometimes one node turns into multiple, sometimes multiple turns into like a couple, and it's really hard to figure out where you're supposed to put those source locations and how you're supposed to stack them together. So I got sick of thinking about it because it seemed like very low value thinking, and I just stopped doing it. And I thought, well, if I ever need it, I can put it back in.
So I think for low cost, I can take the location data I have straight out of the parser and produce it in the assembly with some little fraction of the line and the center point where the parser was, and then completely ignore what you just said about doing optimizations that fool around and make new nodes and delete them, and just carry a location through, anyone, doesn't matter. And
Make
This
it
is
optional.
what I back to doing, yeah, as well.
Yeah.
Make it optional and drop if you don't know which location to choose.
Right, exactly. Exactly. And the goal here is you get something out instead of nothing. Yeah.
I wonder if
do.
there's an alternate strategy. Say you just mapped only control flow things back to maybe you miss.
But
By the way,
you
for the
decide.
questions you are asking in the ahead of time compilers, you may want to look into dwarf work that has been done in GCC and GDB alongside statement frontier nodes or SFN and location views. So statement frontier nodes are basically those stable control flow points where you would insert debug information only for the nodes that can be waypoints of sorts. And location views are actually allowing multiple locations for a single datum that you are going to produce. And this is supported up the stack level. It's actually pretty well supported in MLIR. You can combine multiple locations for a single MLIR operation. This matters when you have something like common sub expression elimination, and you may have something like fused multiply add that was produced from an addition and multiplication. Then you would combine those two source locations for those two operations into one. So that's already implemented in LIR. Down the stack, some of this is work in progress. Some of this may only go into extension of Dwarf 6 standard. You may follow the mailing list for Dwarf 6. There has been some discussion in there. But yes, it has been thought quite a lot in the optimizing compilers like GCC, how to preserve debug information and to have some kind of rich view of multiple locations, many to one, one to many, and many to many, basically.
Right, yeah.
All combinations.
I ran with the hotspot approach and I didn't have to deal. You were optimizing to a safe point, and then if you flip to the interpreter, you did, and then the compiler didn't care.
Yeah, it depends whether you have ahead of time or just in time compilation strategy.
Right. Well, again, this is separate. You can totally have two execution strategies in the same binary. You can have one that's been JITted ahead of time. And
Yeah, there's also been this extension done on LLVM where basically you can debug, you can emit C++ program with two different optimizations level in the binary, and in the debugger, when you switch the debugging function, it's going to switch dynamically to the unoptimized version. So yeah, that also it has been pioneered by self-compiler, if I remember correctly.
That's where self-compiler, right? You just said self.
Yeah.
Yeah, well, that's a hotspot. Anamorphic. That was Sun bought Anamorphic, which was a startup that was starting with Craig Chambers in the self system.
Right.
What goes around.
So if it sounds familiar, then it's for a reason, I suppose.
Yeah.
Actually, at this point, in our Java JIT, we have both. Obviously, we have debug information for deops, but we also maintain more detailed dwarf information. And this one is used, for example, for profiling. When you want to map PC to program location, you don't want to be safe point biased. So we find use for both.
Yeah. Okay.
And we're getting it for free from LLVM anyways. We just need to attach debug information to the initial IR and it gets propagated all the way to dwarf.
Yeah, okay. You say for free, but you've been working on that project for a long time.
Oh, yeah. But the heavy lifting of propagating this through the optimizer, it is part of the LLVM.
It's there. Yeah, the propagation of the optimizer is somewhere along the way there, but stitching it together sounds like a bitch, but I'm glad you tackled it.
Is there a cheap way to do, again, with my own, I'm going to have a debug build. I wonder if there's a cheap way to get easy expression evaluation, or I guess easy being able to know what the value of a certain variable is, because they're just name
Okay,
bindings.
the two different things. So debug info is what is the value of the variable, and that is look up
Yeah.
the variable to get where it was computed in machine state. That's what a safe point has. It has that mapping table.
Okay, yeah.
Okay, so
But then
100%
presumably you have to generate it, and so
yeah,
there's
you're generating this as part of the safe point.
yeah.
It's as if it is a function call that is taken with extremely low frequency,
Yeah.
but as all function calls, it has to have a complete mapping of the state of the universe in case something it calls recursively would deopt. So
Yeah. I'm just
that
thinking it seems like you would have to pin the output of nodes because you know, if variable X is bound to be the output of an add and the add can move around in the
yeah,
scheduler, then you sort of need to pin that down.
yeah. So at a safe point, the parser will, for C2 flavored will do is there is a node. It takes as inputs everything that is the current valid machine state and the mappings, like the current variable names.
Okay, yeah.
So it's all one-to-one. Inside the safe point, there's variable, 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 line, to, arrow, node to computed. Then you let the optimizer go to town. He does what he does. And he will, if you have them far enough apart, he gets to optimize tons and tons. But periodically he stops and says, okay, I have to compute this value, which may be dead, like a known dead from the programmer's
Yeah.
point of view, but the programmer computed it, so he wants to be able to look at it in the debugger, but it's otherwise dead from the output of the program. So it's kept alive by the safe point.
Okay. That's useful. Thank you.
Yeah. And if you want to have a debug point lets you modify variables, then the safe point has to also output all of those things. And that will, screw up your optimizer a bunch. So yeah, that's a thing to choose on. The hotspot version of that was you went into the debugger and if you wrote these things, then the safe point deopted and you went back into the interpreter with your modified, you changed some static final field to something else. So now the interpreter, eventually it rejets and gets fast again, but that's a full JIT picked up your changed final const field and fine. Yeah, it's cool. So at some point I was talking about folding structs and arrays. Are we ready to go there? Or we still got debug safe point things.
We can come back later. So let's
Yeah.
go. Let's
Yeah,
go.
so
I like string structs and arrays.
fold together strings and arrays, structs and arrays, and then methods are just functions that are defined inside that struct that have a hidden this pointer. So the simple parser is already basically, or it's all anonymous functions all the time anyhow. So if you're inside of a struct, I'll just give you a hidden this pointer. Now you have a method on a struct. There's a little bit of calling convention syntax that says I have a struct dot function call or struct function call or whatever it's going to be. Struct dot field of function call, and the field is assigned one of these method values, then you get a method call. So the infrastructure is 95% of the way there already for doing this. And now I can add functions on arrays as sort of first-class citizens. And so an array of cars, an array of bytes, whatever my strings will be. So you have a C string and you have a Unicode string and whoever else, or whatever your string is, it has functions on them directly. And it's a standard piece of the simple language. It is not a special syntactic construct baked in from the parser. It's just a normal piece of simple code.
How about tuples? They're useful.
How about what?
Tuples.
Tuples are lower priority in my head. That's just a unnamed struct that's got types on it.
Yeah.
As far as I'm concerned, that's another almost freebie. Goes in the syntax sugar category of, here's a thing. Like I had that syntax sugar chapter where I added a bunch of common things. I could go back to that one and throw down tuples as a straight up thing. That's not a hard. Like the types.
Can you drop a syntax example of defining a array of things with a function on it?
Let me throw up. Let's see.
It's a little easier to think about syntax if I can see the characters.
Yeah. Let me hit the share button here. and see if I can throw something down here. So I'm going to say I have a struct string, and inside I have the wrong editor. Of course, typing here I have a you can do ASCII only for the moment here. Byte array, bits, stir data, however you want to call it, and I want to have a hash function which has a hidden this. I'll just make a dot to say it takes a this pointer, and the hash function says something like var hash equals 0 and give it equals 0 here. And for int I equals 0, I less than stir pound, I plus plus, then hash plus equals stir of I times 31. No, hash times 31, right? This is the Java one, plus stir of I, and then, return hash. So here is I don't know how you code block. This seems to be Java coded. So this is, I have an array, and I have a field that one array field within it, within the struct, that I can do this game where the user of a string object. So let me make something else in here. What's another thing you have on strings? Maybe string's a bad option here. I just want to have options on arrays.
Length and capacity.
That's usually done on vectors, which we could argue I should do that here. So length is given by the capacity is the stir pound, the string length. So I'll have a length here, and this will be the capacity. This is like same for what you do for a vector, right? Style, and then the hash is probably based on the length field. And then there's an append. So that's not how I want to do it here. We'll say add is oh yeah, here, right? Var, get my vars in here. Add is going to take a dot and a stir. So semicolon there. And now I want to say something like if not stir, return this. So if you add a null, it just doesn't do anything to it. And otherwise, I'm going to say, if stir dot length, if length, length plus stir dot length, oops, is greater than or equal to stir pound. This is the wrong kind of conflict on my names here. I have a local name and a global name. So let me change this to X. I don't have name shadowing bugs to sort out. Then, call expand. And otherwise, there's going to be some array copy, which I don't have here, but I can fake my way to array copy. I want to say stir.copy, that's the lower one, add an offset of length, and the thing I'm copying is x dot his string, and the length I'm doing is x dot his length. So, something stupid like that. So what's going on here is this is an internal reference to this. So this guy has a copy function on him, and that will just have to come for all arrays. There'll be some collection of things that go on a straight up array. But if I want to add a unique function on an array, I'm going to put it in a struct and add some methods. And then when I refer to an instance of that struct, I will can use the method, and he will use it on the internal array. So somewhere in the world, I say var name equals Cliff, and under the hood there is a new. This one is parser thing. I make a new string object who's taken his there is the characters from Cliff. So however you want to do that, So that's the parser, expands that out, dot, dot, dot. And has a capacity probably of 5, and the length is equal to 5. So that would be syntactic sugar for exploding out this thing. I have to go scroll it up here. And last equals lick. And then somewhere along the lines here, I say, name dot add of last. And what I've really said is I have an array of characters in name, and I have another array of characters in last, and I'm just going to do something with them. So the variations on the same thing are going to be map and reduce calls. Like I could have a string has a map. I can do map. Maps I'm just going to throw in on arrays. Internally, an array will be an anonymous struct. And he'll have the type, whichever the type's going to be, and it's the character should byte, and then some functions here. So all arrays that you write will be internally as if they were a true array. And that's in the type system. I have a place that has a repeated array of elements. So I don't know what true array here means. And then I have, map is var map is a function that takes an F and has the array already and goes and does the for loop to make a new array, so he makes a new internal array. I don't know. Something like that, and then has a for loop. I'll link to your imagination, and xs of I is equal to b and f of bs of I, or something like this. And this has to be given a type signature, but you can bar your way along here. It actually can't be a type signature of that kind. It has to be an int to an int. Simple doesn't do type referencing. Okay, so something along these lines where there's a var, a map, a copy, which is array copy, and whatever other things you imagine you want to do. I could do a map reduce. I could add a reduce in here. And there's some init value. Oops, somebody scrolled. Somebody did something funny. Init, so byte, probably byte array. So it's init and a function of int or int from f, and then you reduce things and whatever. So there's a bunch of these things you would put on an array that just come out like out of the simple typing for the user exposed array. Has a hardware array underneath the hood and is otherwise an anonymous struct with a bunch of functions in it. Then you can write your own and include other things that you want to have. And at this point, because there's no inheritance, you'd have to flow through map and copy and reduce and things. As soon as I get inheritance, you would say, I have this anonymous struct, what I'm going to call, or not anonymous, a struct string or whatever I'm going to call it, and it inherits from array of byte. So he picks up map and reduce and copy and clone and whatever things you want to put on an array. And then, maybe an array of ints wants to have a min and a max and a median and a mode and an average and a standard deviation, whatever. Yeah. And then the inheritance would let you pick up all that for free, and then string also has whatever things you put on a string. Like I want to concatenate, so I have an add that lets me concatenate. Now, arrays might want in general want to have a concatenate, so they have a add or concat or whatever you want to do with that. There's things there, but that's the basic idea. There's going to be a struct wrapper. It's going to have a byte array. I'm writing it in simple style, code style, but the implementation of the hood will have a single type struct, which will have an array element that he knows is the repeated piece, and he'll have whatever other fields that you're throwing in.
But I will argue adding the extensions method we talked a few CCCs back, because we don't have polymorphic types. Here the map is defined only for int to int, but if you have a function that wouldn't have an int to int, you have to define it yourself. So that would be easy if you have an extension method down here to say dot map that dot or this, that would be the array, and it would be string to string. So you don't have polymorphic types, and you have to do that.
So there are some other things that depend on, like the wholeness of the language has to have various things. So an extension method, suppose I want to add a method foo to all my future int arrays after some point. So I have some foo function that I want to say takes an int array and does something, I don't care what. That's not an extension method yet. That's just a foo that takes things. So I want to add it to int arrays. So I want to say something like an int array also has, whatever an int array is, also have in its definition somehow this foo, which
so int array plus
is at this point. And somehow I'm trying to say foo goes to all future int arrays.
Yeah.
So if I have an inheritance thing, so some struct of my Theodore struct inherits from int array. So I'm making up syntax as I go, and then I do this thing. I have the foo thing.
So this is easy in Python because types are executed. And it's hard in a language like C or Java because types are not executed. They are pre-known.
Well, so I've played this game with extension, within AA, not with extension syntax, but with extending function calls on arrays. So I'm trying to warp this into simple syntax on the fly in my head. I'm not necessarily getting there 100%. But there's something that says I can add a function to the static class hierarchy of the original int function, and I will use this for all future function references.
Yeah, if it's mangled in by the compiler versus
no. I mean,
at the
I'm
call site.
writing something here. Now, TED is a bad name for me doing an int array. That says things like I can do the length of the TED array, maybe, yeah. And then I could say, TED of 2 equals 99 because it's an array and I can assign to it. Picks up all the things. So this works out in AA without executable types. It's just straight up hard typing all the way down the line. It's full on static types.
The question was provoked because you have a map, but the map only have the signature. You have to define. We don't have either overloading either, so you not have a map defined for ints and strings inside the struct, the anonymous struct, which would be the array. And if you want to dot map something, you have to add it after the fact. So at least a question for the future simple evolution, would it be extension methods added? So you will have the map, which var map,
right. So the
I
issue
would know that it's an array, the first argument, and then you define from string to string.
So the thing going on here is that extension methods are a thing that make something syntactically an invalid syntax to be valid after you discover the extension method.
Yeah, that's true.
Okay, and what I'm defining here is I get a new type from an old type that I've added the extension to. Now you use the new type, and at this point I don't have the issue that the prior code suddenly should have had access to the extension and didn't and wasn't valid. So the parser can do a one pass top to bottom and know what it means. Whereas if I put the extension at the bottom of the file, but I use it at the top, the parser doesn't understand what it means. And in my case, he'll actually just throw syntax. I require
let's
two
say
full passes.
It will assume that, let's say if you call that on a string to string, it will assume that it's an int and throw an error at you because it haven't reached the extension point the method of user.
That's another way of saying after the extension is defined, it's valid and it's not beforehand.
Yeah.
And my theory on this one is the int type itself doesn't modify, but I'll let you have a subtype which adds new things. And then I don't have to deal with you passing a modified int array around to a function and expecting to get the modified one back unless you have declared it as such already. So I'm not clear. Like
so
the simple's not doing any type inferencing. It's not doing Hindley-Milner of any
yeah,
kind.
yeah,
So there's a lot of things that I just can't assume that I'm going to flow through the typing system. It's the same reason I can't have this piece up here be a var and it just infer. Because it's a forward flow only typing. I need to have the type of that argument because I can't look ahead and then go back to the type and say, oh, I found it was taking an int and returning an int. Too late, right? So I can infer in many cases, but not always. Here, var map, I infer because this one says map's not defined yet. So I'll just hang on to map as a name in the parser and it's just off to the side. And then I'll parse this whole expression, comes up with a type. Well, that's the type for map. Okay, inference is easy for that case. Functions are the place where I can't infer. You have to give it to me. And here I would claim still an error for an array of ints. Your map has to take an int and produce a string. Like I just want to say toString on my array, and I want to call toString on all my ints and get an array that has a string that has, bracket and all the ints printed out in an ASCII string. Okay. And my debugger does that as I hover with the mouse on it. Oh, that's great. I love that. But now I need an int to string function. But if you say string, but you put it on an array of ints, that's an error.
So that would be here. So that would be an error.
Yeah, this one would say the implementation of map will give you an error because I don't know what this array is. So you've said I have any old map. I don't have type variables. You can't put an array. You have to say an array of something. Give me an array here. So you put int there. As soon as you put int there, or I'll put int there. As soon as you put int here, your implementation of var map. So this is your signature. So bar is this, arrow, and now you have an implementation. This implementation will fail because he's loads an int and he's going to call a function taking a string. So you have to do this, right?
Okay. Oh, so we will have an int array which kind of extends an array or string array or something. The variation will be defined by subclasses. Okay.
Now you want to say syntactically that something I did like this dot here says map should be applied anytime, should be allowed anytime I see an int array on the left-hand side. And I have a variable name, but it's fine. It's my byte array or my int array, whatever.
Okay, fine. Yeah. Because
and then this would say for next future things, if I said, whoops, no, come back here. Why did I not go down? God damn you, Google editor. It's a really bad code editor. What was I doing here? Var, I'm going to make some ints, int array, it's equal to a new int, and I'm going to invent some syntax just so I don't have to, do things. Okay, fine. And then I want to say, is.map is allowed where this pointer comes from the left-hand side and the right-hand side is some string, which is, ints have a string operator on them. That's your function up there. And that would do the obvious thing and say, give me a string array from an int array, right? You printed the damn thing. So this version of map actually just walks the elements one at a time, gives you a section of strings. If you want a two-string version, you'd have to join them all. But the key one is that this is the extension call. And can I look that up? So right now what I would do is I look up the type of IS, discover it's an int array, look for some map that takes int to string, not discover it because my current map is only int to int. Fine. And then say, I would fail and say I don't see the type variable that has I don't see the variable named map, a field named map in the int array class. Without a field named map, I blow up on you. If you have multiple fields map and they have functions, I can do type function. I think I can do type overload.
Okay. Let's say you have the int array defined at some here up in the uppercase. When you encounter the map, can you add artificially that as if define it?
Right.
It will have a special section of the extension methods, and it will at least associate it, so it knows it can be called.
So what the parser would have to do, so all types are final and immutable and never can change ever again. That is part of the nature of types. So the int array type never had a map of int to string, so it never shall. What the parser can do is say, I have a new type that I will use whenever I see an int array type, and my new type is all the things int array does plus some new things you've added. But from the parser's point of view, he makes that new type. And it's only valid from this point forwards in the parse, which is weird lexically. So I probably would have to say, in fact, as you exit, you lost the exit a scope, you would lose the definition, and your extension method is only valid within a scope. Yeah, I think that might work. That might work.
What you said, and like a special place that you add extensions, and when you leave the scope, you drop all the extensions defined in the scope.
Same as we have to be careful. Yeah, you use it. Yeah, you drop it for no. If I then take the new type I made, see right now in simple, I don't have types nested. They're all top level on purpose. If you make a type in a nested scope, that type can't escape that scope, or if that type escapes that scope, I have to be able to do valid type things on it, but I've lost the original type definition because it went out with the scope. And then you end up using your extension method pass, because you take the extension method and you make the array that in the scope of the extension is valid, and you throw it into a collection of all int arrays, some with this extension and some not. Then you exit that scope. Then you pull a thing out and you say extension call on it. Oh, I see. Then you would say no, because it's purely a subclassing operation. It is a downcast or an upcast, or where I forgot the extension method after the scope, and you wouldn't be allowed to call. Oh, but then you could go back in. No, if you went into the different scope,
it still has to be valid. So it's the extension, as you said it will be only valid for a current scope. The nested scopes can see it, but not once you
closures, which I don't yet. If I had closures, I have lambdas, not closures. If I had a lambda, can I screw myself? So I export a lambda who makes the extension and did the arrays, and I made the extension, did the arrays, and then I want to pass the array out. But I can't refer to it again. But you can lambdize it. So you can make the array in the scope, pass it out of scope, then also pass out of scope at the same time a lambda who understands the extension type, and then passes the extended guy back into the lambda who takes as an argument an extended version. So the type becomes globally known from the parser's point of view, but only locally executable from inside the scope where it's defined. But the parser has to track the extension type as a unique version of an int array for all time, and there may be several of them with different extensions that are actually semantically equivalent.
Yeah. Okay. But let's back up. Let's back up from.
Yeah, that was pretty deep down that rabbit hole. So this is why I'm not touching extensions yet. There's a rabbit hole that goes really deep there.
Yeah. Okay. Cool. Next topic.
Next topic. Okay. Fine. And a big piece of that, going down that rabbit hole, is you bring out Hindley-Milner typing. And then the rabbit all works, and then you get closures and all kinds of shit happen at you, and it's fine. But and that's what Scala did. But if you're not Scala and you didn't do Hindley-Milner mixed in with things, you got to do that rabbit hole.
Scala doesn't do Hindley-Milner. It has
flow typing.
Yeah,
it doesn't. Really? It can't, because of subtyping. It's hard.
Okay.
But
all right, fine. I claim that I sorted this out in AA, but I haven't been able to implement because instead of doing simple, because simple's gotten traction, people just want to see a classic compiler done. Fine. There is a way.
I had a crazy question, which I don't know. Maybe you guys talked about this once. You talk a lot about optimization and register allocation for CPUs, but these days a lot of people are doing stuff with GPUs. I was just kind of wondering, is that all done basically in libraries, and that's
Oh,
the
it's
right
got
way
a
to do it, or is
demo.
there?
So Arthur asked for a demo of the register allocator, and I should do that. So if Derek is online and willing, I can also show PE allocation, a simple PE allocation.
Yeah, sure.
If you care. Okay.
And to quickly answer the question, the GPU is often compiled using the GPU driver. So GPU driver is essentially a JIT compiler for a GPU. It can take code for CUDA and something like PTX and go emit SAS assembly.
Okay, so like the target is the GPU driver.
Yeah, GPU driver is essentially a contains a JIT compiler, and it can compile to a specific GPU card that is physically present at the machine. And
I
that
see.
does the
Okay.
thing that, and it does those things like register allocation, instruction
Okay.
scheduling. That's
Let me-
essentially a backend lives in the driver, one could say.
All right, I'm going to
Thanks.
change my screen presentation. There's some bad interaction between Zoom and
For reasons that are mostly accidents of history, CPU vendors published assembly code and machine code and said, just give us a binary to run. And GPU drivers were like, no, we want to constantly be changing the architecture that we run. So they often didn't have a stable assembly or stable binary between versions of the GPU. So you had to rely on their driver to translate.
And those changes have been fairly significant. You could even go from a generation to a generation from something that looks like RISC to something that looks like CISC, or I should say the load store architecture between NVIDIA CUDA versions. If you were looking at the SAS assembly, that is the lower level than after PTX, you would see that some instructions for one GPU card would use memory operands in arithmetic instructions, whereas the next GPU card would actually break this down into purely load store instruction and then arithmetic instruction. So that's just jumping from one GPU card to another.
So I'm curious with people on this call, do you think that was a good or bad idea? Like, should GPU vendors now start publishing a standard assembly for their GPUs?
I actually think it worked out for CUDA, for NVIDIA pretty well, because they were able to make those far-reaching microarchitectural and architectural changes and completely redesign their GPU card architecture, and then it was invisible to the programmers. They didn't build up this legacy that you see in x86, for example, when you have to maintain hundreds to thousands of instructions.
It's valuable to NVIDIA because it creates a moat for their monopoly. That's the biggest reason.
Well, I would say I wouldn't view this cynically. I think it literally allows them the freedom to change architecture from one GPU card to another, and you wouldn't have that freedom otherwise.
Right. Like if you were an alternative GPU vendor, you would consider doing the same thing for the same reason. If that also made a moat in the marketplace around that, so it does. But that first reason is I can keep changing shit and then keep getting performance.
Yeah, I think Apple's metal does not match CUDA.
It probably makes sense historically, but maybe not so much now. Definitely GPUs were revved significantly, but you presume that they converge at some point to generally some specific thing, and then it starts to look a lot more like a kind of really SIMD'd CPU, or I guess SIMT'd CPU.
Maybe, maybe not. I mean, even between Ampere and Grace, you would Hopper actually had pretty significant changes between A100 and H100. I think the only deviation from that is actually tensor cores, because tensor cores are a little bit oddly from that nice story point of view, is that they actually started to do low-level GPU card specific things that even show up as high level as CUDA. And now you can have something that shows up to a high level CUDA programmer, assuming that CUDA programmers are high level programmers, that will work on one GPU card but not the other. That's kind of breaking the tradition of having those nice layers of abstraction. So we will see how that evolves.
Okay.
So what do we have here?
Yeah, you have assembly output for a couple functions. And let me go show you the raw function, and then I'll go back to the assembly here. Font shrink. So This is a test. I have a couple versions. I can pull up. Brainfuck might be just as easy, I guess. And here is an equals call on a string where the self and string, so it's just two function calls. And here's a sample string object. And he tests for equal, and then he tests that the lengths are unequal, and then he walks the two arrays, and if the characters aren't equal, true or false. Boom. Hash code has a cache that says it's null, and if it's not null, not zero, take it. If it's zero, go compute it. Or hash code string computes the hash we just looked at, and then forces it to never be zero, so you don't get a zero hash. And then I make a junk thing and call stuff on it. So if I go run this, a bunch of stuff. We'll go look at the assembly dump. So here is the header. It takes this struct. It's called a string struct. It has an array of bytes and a hash code field. And it has a second string struct. There's two of them. And self is passed in RDI and S is passed in RSI. So immediately I have calling conventions. And then there is a compare RSI and RDI. And if they're equal, you're going to jump to 52. And if they're not equal, you're going to fall into 62. And 52 is going to take that RX of 1 and say equals true and return a 1. Then I'm loading in fields, and I don't have the field references, but I fully know the types and the names. And the fields here are going to be the arrays, I suspect. And then I load the array lengths, and then jump on equal array lengths or unequal. And then this is, fail or success. The capital jumps are virtual jumps. I haven't done basic block layout. That'll come as part of encoding. And so a lot of these capital jumps actually go into the very next instruction, and they'll just encode as nothing, and they'll disappear from the assembly. But some of them jump other places, and then they'll be encoding as for real, as just a bare jump to straighten out the basic blocks. So there is, where's my 73 here? Here's a loop. Tested it and run the in, so I is in register 8. Somebody asked about Sam asked about safe point info. Well, here is something I know. I is in register 8, and I may have to in, yes or no, jump out or carry on, compare a byte. If equal, carry on and increment your byte counter and go back up to the loop. And if unequal, you're going to exit here, go to 69, which is going to load a 0. And then I have a bunch of trues and falses, and we exit here. So can I clean this up a little bit? Yeah, a little tail call folding would make it a little tighter here. There's no real spills. There's no spills in it at all. There's only a handful of registers. So easy cheesy. The hash code guy only got called from main, so main inline hash code. And so somewhere in here we see this kind of thing as the loop 10, where I have a hash and racks I'm trying to accumulate, and I have an index I, and but this is kind of a hint. It's not true or false. I happen to know the length is fixed, so I'm out of here if you're under length. And then I'm grabbing your guy, your character, your hash, and then shifting it by 5 and subtracting. That's the multiply by 31. And there's looks like a self spill. So that comment to the right says this is a spill op for some reason. And then he loads the byte array, the byte from the indexed offset, and adds it to my hash and increments my I and jumps. So here I have a couple spills in the loop that are just reg moves because I'm shuffling around a hash and a loaded value. And I could go stare and see if I could probably get rid of one of them, and I might not be able to get rid of another, I don't know. And then when you come out, you're going to test for 0 hash and stuff something in. So, I don't do any conditional moves right now, but that's a prime conditional move example. Store the hash so it's recorded for all time and return in racks. So the hash is in racks here. So, not terrible allocation, I claim, and maybe a little better, a little worse, but it's not terrible allocation. So there's a sample one. We get here again, we're going to be on risk. And here's the risk encoding of the same thing. Bunch of loads, branch 2 registers equal. set somebody as 0, so you can start doing counters for range checks, and then you're going to add 4. Which one is this one? This is the, oh, this is because he doesn't have the damn offset code. This is grabbing the length and the offset to the length, and he's got something. Is that right? Load 1, jump 67. I'm going to be reading the assembly backwards here. Where's my loop? Oh, this is the compare then. Okay, so this is a thing where I don't have a risk, doesn't have a base plus offset plus index mode. I have to do an add of somewhere, and I need to do a reshuffle to get the add of 4 out of the loop because my base pointers are unchanged. So one of the rules I have for simple is that base pointers are they are exactly the base of an object. They're not obfuscated. They don't have any derived pointers. So R6 and R7 are the base of the 2 character arrays, not the 2 character arrays plus 4, which would skip the length that is stored at the base of all arrays. So I have to do an add. I could get rid of the add by putting it outside the loop if I had a derived pointer, which would fuck with me if I later decide how I'm doing garbage collection. So I haven't done freeze. I got allocations and no freeze. So one of the major things has to be done here is exactly figuring what to do with free stories, which right now means I'm keeping my base pointers around, not doing derived pointers because they're complicated to get squared away right away. So get an add in the loop. If I didn't do garbage collection, then I wouldn't have a derived pointer, and then the add would go out of the loop. Fine. And then you load up 0s or 1s and exit. The other guy has his setup for his allocations. Here's all your allocations. I make a string array. I make a string object. I stuff in the fields for the characters CL, IFF, and then I just did the 2 CL, and the length and the size of the struct and everything else. And then there's the hash computation got inlined because that's all I did here. So that's, am I at the end of my, is R6 less than R3 in my array? Go get the array, add the offset for the array length, shift the hash by 5, subtract off the 5, go ahead and load the byte from the array, add that in, add 1 to I, and jump. So no spills listed here, but there's a few shuffle spills up here happening because I needed some temps, and there are callee save registers, and the arguments that got passed in are not in the callee saves, so I have to put things into callee saves. That's what happened there. So what happened there? No, this is what the alloc demanded a certain register. That's what happened there. This is a def empty 1. I have a define with no registers. That's the empty. And the single register define is because I called R10, which is the argument register. This is a function call. So it crushes a bunch of registers. It produces a value in R10. This guy also is going to crush R10. So I have to move this to a callee save register. That's what happened there. So call or callee save registers. Go read your assembly. Here's the ARM version, the same thing. Slightly different register names, slightly different layout of things. It's very similar. It's a RISC, so you get the same kind of things where you have the loop where you're just running through comparing characters. And you have the same add because you have the same derived pointer problem. And then the other loop here for hash. And no spills in the hash, but there's a little bit of reg shuffle around the allocations. Fine, there it is. So there's that. Yeah, merge sort or brain fuck. The merge sort has ugly spilling, so we could look at ugly spilling on merge sort here. Except I can't. Hello. How about now? There it is. Stop that. Go to merge sort. Go to, well, let's see if I could do it just here. It would, except I didn't put my breakpoint in. Come back here. Okay, so merge sort. A lot of things happened. And then, code goes on, and then it ends for merge sort, and there's main. But if you look at the code for merge sort, there's a lot more stuff. It all gets inlined except for the split merge. So main picks up a bunch of array copies, allocations of the two arrays he's going to merge sort on, and or the one array and the target array, and he fiddles them and he fills it with junk, and then he calls merge sort, and then he's returning the answer down here. So merge sort himself has the big merge code that recursively calls merge sort twice. And so you get this horrific thing up front. So a couple things to notice here. There are your call save registers on x86. I ran out of registers because I have calls and recursive calls, so I have call saves. Those aren't put in any way special in the allocator. They're just defined as a live on entry consumed by the return on exit. And they have a single def and a single use outside of all loops and cover a huge area. They are ideal spill candidates. So as soon as you have a spill requirement, you spill these. So there's your prologue and epilogue, but I didn't write prologue and epilogue handling code specifically. It just came out. I have a bunch of shuffles of moving my arguments. I have 4 arguments. They all get moved into call save registers so I can keep them alive around the call. And then another shuffle to get them in the proper place for the next call down. And then again, shuffle down in the second call. And the split merge takes a high-low halve, so he shuffles the arguments. It's beginning and end and middle and something, and he shuffles the begin and middle, 3-way shuffle. So it always has to be a register shuffle here. And the computation here has to use racks and dx because there's a divide, because you take the high, the low, and you add them and divide by 2, and you get the middle point. So that's why all the shuffle here. It's like pretty nasty shuffle. The actual merge sort just says, okay, do I have equal this and equal that? And then I'm going to pick one from the other. If you're small, if you're big, I split you again. You know, recursively go split again. If you're small, I grab this guy and I grab that guy and I test. And I went left or right and left and right. And here is a thing that I don't have is a peephole optimization in simple, which is what in Java I would call unzipping. I'm testing a condition and I picked it up from a couple places and I'm merging in, and it's a 3-way condition because it's like if you're 2 items, you less than the other, flip or don't flip. And if you're 3 items, do the 3-way. And if you're 4 items, you went to the recursive merge. So when I got down here to this test of should I shuffle them or should I not, I came in from like 3 or 4 different paths. The unzipping transformation, he gets a Boolean down here. And the unzipping transformation is when I say I'm testing a Boolean, but I put a Boolean in a register. Instead of put the Boolean in the register, go backwards and split this test into 2 different places where the Boolean is constantly true or constantly false. And then you would jump. So the standard way this happens in Java with a null pointer check is that you did some code and then you did a null pointer check. And you went one way if it was null and another way if it was not, and you did something, and then you merged back together and you forgot that it was null. Then you ran along a little bit of code and you tested for null again on the same thing, and you split again, you went and then split, and you went and you split, and you went down and down and down. And so the unzipping is I have a bunch of these diamonds, diamond, 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 and in between each diamond is a little bit of code. So I unzip the diamond like rolling a zipper apart, and each of the little bits of code clones in left and right. And I test it once at the beginning, and I got the left and the right. One is null, one is not, and then a little piece of code, and then one is null, one is not, and a little piece of code. And the no's that I know you're not null or yes null just goes away, and you get the little piece of code, ding, 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 all knowing null or all knowing not null going down. And then you merge at the bottom. So similar problem here is I'm building a constant 0-1 Boolean, and then I'm forgetting it, and merging and forgetting it, and then I'm testing and splitting. And I want to take the merge of a Boolean and a split and split through it, and so I have test twice.
So essentially, we split the path for the both conditions. But if you have 2 functions, wouldn't that alternate? You have for the second function you have the no checked remove and the no checked present. Wouldn't have the test.
As soon as you have complicated things and those little merge spots where you don't know what's going on. As soon as you have complicated things, you have to make a profit heuristic because I'm going to clone that code. And it's not always profitable to clone a call.
Yeah, if you have 5 functions, you can always split the case that you have all the 5 functions that are known that with the no check remove, because you know that that there is a value. But how if they're when they're executing.
So maybe we get concrete here. Let me go.
Yeah.
Let me go bring up the Google Docs.
Okay.
And let's put some concrete examples in here. And head down to another blank line. Oh, I have to share Google Doc. Share. Boom. Okay, so it's like this. I'm going to test something. I'm going to do S0 else S1. Now I have some shared code. So I'm going to call this, I don't know, E0 and E1. And have some shared code, shared S0. And then we'll repeat this. Okay. So in this version, I'm repeating the P test, but I have some shared pieces. The P test could be a null check or it could be my Boolean of exchange these two elements or not, right?
That is amenable to splitting all the path, that if P is known to be true or false. Okay.
Let me go look at the split versus not the split, and we'll see if it's amenable or not, because it's not always amenable. So this side says E0, S0, E0 again. So these E's are meant to be replicated as new codes, 2 and 3 and 5 and 4 here.
Yeah.
And they're often completely empty.
But in essence, they will always test the P for its execution. So
would it be S1 and then E4?
Yeah.
And then down here, it's going to be E1, S0, E3, S1, E5, and then S2 is down here. Okay, so in the lower section of code, I'm going to scroll up a little bit. In the lower section of code, I have replicated S0 and S1. They appear twice. So I've strictly added more code. I've inflated my graph. So you have to have a profit heuristic that says S0 and S1 are cheap enough to clone up. And then if they are in turn function calls aren't too expensive to clone up, but it doesn't necessarily help me to know that I have a null or not the null directly here. It's if I'm going to make profit out of knowing your null or not when I call S0 or S1, I typically inline them. And now the S0 is the inline body of whatever function call was there. And now it's big. And now maybe it's not profitable to do this transformation. So you had a separate thought, which maybe was going on in your head, which is if S0 had a not null argument, if it had a not null argument, the original code is incorrect because it didn't check P for null when you called S0. So S0 does not have a P is nullable or not nullable, or you were just broken program from the beginning. So in the case of the merge sort, where I have these flip you left, flip you right, do I swap elements or not? Do all these tests and then choose to swap or not? The thing I'm missing here is exactly this transformation where P is the Boolean, which right above the original code here, and S1 and S0 are both array swaps. So I have a Boolean P is equal to the result of, some element is less than E1, or E1 is less than E2, or whatever it's going to be. It's whatever you do in a merge sort here. There's like a three-way compare. You decide you're swapping elements or you're rotating three ways or whatever. So there's a complicated series of things that are setting this P, and then there's one or two swaps. There's actually two Ps, and you're swapping 1 and 2, or you're swapping 2 and 3, or something like that. I would be better off moving my if test and the swaps. The swaps are 2 lines of code, 2 lines of machine code. They're, load from array element at this index and store into that one. And then there's a jump to get out of there, and I can clone that. So I'm better off moving the clones up by doing the splitting. That's not a thing I'm doing in Simple right now. It's totally a doable transformation for Simple. It's just not one that's been done.
So the main paths as if on the one side will be E0, E2, E4, on the other will be E1, E3, E5.
Yeah.
So wouldn't that amenable to this piece of code, like the global variable numbering, doing the same test or something?
let me pull up here the merge code from simple, and I'll throw it in without losing the Google Docs here. So the merge code is walk from beginning to end, and if you are I less than middle and I less than end, a cond is true, cond is false, else con true. If con, slip left or split you right. So the cloning would say, if I'm in the section of in the middle, then I'm going to put this version, the true piece here, and the true piece here, and else I'm going to put the false piece, whatever, there. And the code isn't so pretty, but that's the job of the optimizer to, like, make life fast, not pretty.
Yeah.
But,
Okay,
but if
so
I'm
that is in the essence the unzipping thing.
yeah, that's the transformation that's missing, or that would clean up force things into a Boolean, so that the code that gets generated from the compiler is it produces the 0, 1 to register. Then it tests the register. And instead of putting the 0, 1 in the register, the test that produces the 0, 1 should be tested directly. So that's the transformation that's missing. It's a standard optimizing compiler hack. Fine. Just didn't get done with it. Hadn't got there yet.
Cool.
So that was, for Arthur's sake, that was register allocation. If you had another question or you wanted to see something else, I can throw up something else. And Arthur's quiet.
Oh, that was fine.
That was fine. You got what you wanted to see. Same
Yeah.
for Risk and ARM and all of these guys. If I come down here and look at the bottom, the 46 here in my, oh, I'm share the screen. Hang on. I might be able to do the other guy too. So Google, I got too many windows. The share is unhappy. When I run the test, I tell you architecture and calling convention, and then 46 is the count of spills scaled by loop nesting depth. And we see for Risk and ARM, they have far fewer spills. We got more registers, so that's part of the name of the game. All right, I'm going to do one more of this AI chip thingy. Which I probably didn't set a breakpoint to stop and look. Oh, it's because I was busy hacking it, and so it's going to die before I get. Oh, that's special. What happened here? Yeah, fine. I know what happened here. I'm out of a build cycle. I might not be able to do this because I'm mid build thing. Let me go see if I can make this happen. So I have a release build of simple I'm using in this project. So it's the same compiler with just a different backend description. And I got out of sync, but it's not too hard to get in sync. Okay. Let me see if something happens here. Yeah, okay. No, I can't print. That was part of the out of sync thing. Why did I not print? All right, it's not gonna happen right away. I hacked my thing. I even know where this one is. I can fix this one. If there's another one, I'm not making progress fast enough to do it on a live video. Mid hack, so you get what you get, right?
Yeah.
Where was the address? It blew up on mem op. Oh crap. Maybe not. Down here. Yes. And no, he called an out of bounds. Why are you calling it here? Why are you calling it here? Oh, no.
We can probably start the next CCC with an example of that because it's time already. So no worries.
Oh, it is. I figured out where it is. So can I rapidly do this here? I'll do one more, and then we're gonna see if I get it here. I'm hacking an Emacs to try and get this to go, and I'm not even gonna test. I'm just gonna run. It's gonna fail because it's not here. It's called. I have the name changes between the two, and for no good reason. No, this should be a simple flavor now. Okay, and now, what now, brown cow? Oh, something. Okay.
Cool.
Okay, so RISC-V 32-bit or 16-bit, 32-bit. So R8, R9 are Kali saves, but there's only 16 total registers. Broadcast is moving on to a constant value into the SREG on the DSP chip. There's a 1 and a -1 being loaded in A0, A1. There's a load of a byte into A3. There's a format for the Mac. Here's a Mac machine, a multiply add. There's a multiply going on, but no add. In this particular case, it changes the format. He loads another byte. He does a multiply add again. He takes in fixed registers D012, puts out fixed registers D012. Those are the accumulated values. He hides away one of the things because he wants the sign bit because he's doing a negative check in the actual test. He grabs some other things and does the same multiply accumulate and another multiply accumulate. And then kmask is a conditional move, and he's setting the conditions up, and then he's picking a 0 or 1 out of the conditions according to the things he loaded and the multiply accumulates he got. So out of all that, he gets like most of the instructions actually have fixed register uses. You get one spill that he had to do. He has conditional moves. He has fixed reg multiply. It's like an Intel multiply takes a CX or AX and DX. Here he takes A0 or A1 times a generic register added to D012. So there are 6 registers as inputs to those instructions, of which most are fixed, plus a bunch of hidden registers like formats and input register. And the SREG is an input register. So like Mac actually has like 10 input registers, whatever. So he does a reasonable job. So there's some scheduling hacks going on to make him schedule the instructions so they don't overlap badly. And then he doesn't have to spill the deregs all the time. And the actual computation is 1 multiply and then a second multiply accumulate to the first guy. So it's 2 multiplies and an add. And then again, 2 multiplies and an add of a high precision value on a machine that's geared for doing low mixed precision ops, because there's a lot of the AI things do super high volume math and very low precision numbers, which is what he's set for. So that is one run through of one of his things, and the chip has many, many thousands of these things. So, and then each one would get some collection of different instructions or whatever. So it's an interesting chip that has all kinds of cool things it can do. And certainly it has high flow rate for this kind of stuff. Fine. But the register allocator, the same one in simple, is doing this. So it's doing a reasonable job giving an interesting situation there.
So it's just yeah.
There's a very specialized ALU which with a little bit of stretch and a little bit of overuse of multiplying and accumulating, you can do kind of fairly general purpose things. And so that's a test of a slightly more general purpose thing than what we would normally be doing in that device.
Yeah, normally he has hot loops that run for hundreds to thousands, and they have edge cases left and right. And then the main body, they do either multiply accumulates, or he has matrix multiply for small byte counts, for small counts of bytes as a hardware op.
Yeah.
So you get generic matrix multiplies, or you get generic multiply accumulates by the bajillions. And network on a chip, so he has sockets to other neighboring things. So the sockets are in loops as well, doing I/O across the chip boundaries, or the processing element boundaries to the neighboring processing element.
Yeah.
All right. Yeah, we're time, but the allocator is functioning fairly well. Could be improved, but it's not terrible. It's a reasonable allocator.
Cool.
And if anyone wants to volunteer to take a look at the allocator and code review anything or add more comments, I have added a bunch of comments in the README. If you're interested in how the register allocator works from a high-level view, there's a nice write-up now. All right, and then until next week.
Bye.
Thanks.
Bye.
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 Bye bye.